This is Advanced Math 6.2 notes. That's Unit 6, Lesson 2. The title is Angle Addition Laws and Solving for X. Quickly, sine of a plus equals blank and tangent of a plus b equals blank. I'd like you to hit pause and fill those in on your own. Check with the previous lesson 6.1 notes and see if you got them all correct, and then move on. Okay, angle addition laws. Using a squared plus b squared equals c squared. That's what we're going to do first. And given, you're going to be given information. Sine of u equals 4/5, where u is in quadrant 1. Cosine of angle v, it's a different angle, is -12/13, and v is in quadrant 2. Number 1, find sine of u plus v. I'm going to leave some space because I do want to draw a picture. Find sine of u plus v, angle u plus angle v. Remember, we cannot distribute the angle. I am going to use my angle addition formulas. I do need to draw these pictures first, and this picture I'm going to draw is going to go for number 2 as well. Now, you do need to know which quadrant to draw it in. They're either going to flat out tell you, like it did here, or give you some kind of constraints, restrictions, some kind of hints so you know where to draw them. Okay, u is in quadrant 1, and sine is 4/5, that's opposite over hypotenuse, and you should know this one already. This would be a +3. Okay, angle v is in quadrant 2, and cosine is -12/13. That's adjacent over hypotenuse. You do Pythagorean's theorem, and this is 5. Okay, and it's +5 because it is going upward. So what we're going to do is just expand it using our formulas, because we cannot distribute sine, and we don't know what angle u or angle v are. We just know what the picture looks like. So sine, the formula sine is the friendly one. Sine of u cosine of v, same sign, plus sine of v, since I've already used angle u, and cosine of u, since I've already done cosine of v. Okay, sine of u is 4/5, and I'm just using my picture. Cosine of v is -12/13. That was kind of already given to us anyway. Plus sine of v. Sine is opposite over hypotenuse, so 5/13, times cosine of u, adjacent over hypotenuse, 3/5. And you work it out. That gives you -48/65 plus 15/65, which equals -33/65. Final answer. Okay, number 2. Find sine of u minus v. Okay, so again, we're going to expand. It's the friendly one, and it keeps the sign, so it's going to be pretty much the same as this, but with the minus sign. Sine of u cosine of v minus sine of v cosine of u. And you can pretty much copy the fractions up here or go back to your picture. Sine of u is 4/5. Cosine of v is -12/13. Minus sine of v, we're on v, sine of v is 5/13. and cosine of u is 3/5. Again, which is the same as what we ended up with here, except now it's negative 48 over 65 minus 15 over 65, which comes out to be negative 63 over 65. All right, and that's the kind of stuff you're going to be working with the angle addition laws. Moving on, number 3, we're going to solve. All right, so a little different from the one we just did. Number 3, we're going to solve. Sine of x plus pi over 4 plus sine of x minus pi over 4 equals negative 1. And we want to solve for x. What values of x would make this equation equal negative 1? What you're going to do is, just what I did earlier, use your angle addition laws to expand them out. Do not distribute, expand. Sine of x cosine of pi over 4 plus, same sign, sine of pi over 4 cosine of x. Okay, I will change colors, plus now I'm going to do this one here, and it's expand again, sine of x sine of pi over 4. Sorry, got to change that piece there. That should be cosine because it is the friendly one. Okay, so let me just fix that. Cosine of pi over 4, same sign, so it's minus sine of pi over 4 cosine of x equals negative 1. Okay, let's see if there's any like terms to combine, and sure enough, I have a positive sine of pi over 4 cosine x and a negative sine of pi over 4 cosine x. Those are gone. I have sine x cosine pi over 4 plus positive sine x cosine pi over 4, so that's 2 sine x cosine of pi over 4 equals negative 1. I'm going to go ahead and get rid of that 2. You can get rid of it now or later. It technically does not matter. I'm just going to get rid of it now. So I have sine of x cosine of pi over 4 equals negative 1/2. What is cosine of pi over 4? Cosine of pi over 4 is 1 over root 2. So I have sine of x times 1 over root 2 equals negative 1/2. I'm going to, instead of dividing both sides by 1 over root 2, I'm going to multiply by root 2 over 1. That is the same as dividing by 1 over root 2. Cancel out. Sine of x equals negative root 2 over 2. I'm going to draw an arrow over here. If you use your unit circle or have your facts memorized with root 2 over 2, you're good to go. If not, I'm hoping you just flat out remember that root 2 over 2 is the same as 1 over root 2. I'm just going to make it negative because it was negative to begin with. If you forgot how to do it, I will start you off. You multiply top and bottom by root 2, and you end up with 1 over root 2, negative in this case. Okay, so sine of what angles? We know our reference angle is 45. Which two quadrants is sine negative? Here and here. What is 45 degrees in those two quadrants? 225 and 315. And that there is your answer. Okay, number 4, another solve. Tan of pi plus x plus root 2 cosine parentheses 3 pi over 2 minus x equals 0. So we want to find the values of x that will make this function equal 0. Again, we cannot distribute tangent or cosine. We have to use our angle addition laws. Okay, so let's expand the tangent out. That's the one that expands out to a fraction. So I have tan of pi plus tan of x, and then 1 minus the product of tangent of pi and tangent of x. That's it for the tangent. I'll change colors. Plus the root 2 goes like this, root 2 parentheses, and then I'm going to expand the cosine. That root 2 will have to be distributed inside. Okay, cosine is the snobby one, so cosine of 3 pi over 2 cosine of x, opposite sign, plus, and sine sticks together, sine of 3 pi over 2 sine of x. And the whole thing equals 0. Okay, I can tell even if I distribute, nothing's going to cancel out, so I'm just going to work out where I can. What I mean by that is look for angles that are given to you that are not x's. For example, right here, tan of pi, that's something we can evaluate. Tangent of pi, there's no x's there, I can evaluate. Cosine of 3 pi over 2, sine of 3 pi over 2, all of those values there I can evaluate. Okay, tangent of pi, find it on your unit circle in your head, however you have it memorized. 0, that's what tangent of pi is, plus tan x, I don't know what that is, over 1 minus 0 times tan of x. 0 plus tangent is tangent. 1 minus 0 times tangent is 0. So I have tangent of x over 1, which is simply tangent of x. Okay, I'm going to continue. You can distribute now, or you can evaluate first. It doesn't matter if you want to distribute now. Root 2 cosine 3 pi over 2 cosine x plus root 2 sine 3 pi over 2 sine x, and I'm going to go back and circle the ones I can evaluate. That one there and that one there. 3 pi over 2 is 270. Cosine of 270 is 0. So I have plus root 2 times 0 plus root 2 times sine of 3 pi over 2 is negative 1 sine x. Okay, so then I have plus 0, that's just gone, minus root 2 sine x. So it was messy, but it did clean up a whole lot. Root 2 times 0 is 0. You could put a plus 0 in there if you'd like. Root 2 times negative 1 is negative root 2. That's why I have a minus there, and then sine x. I want to solve. Can't factor, can't GCF, can't do any of that stuff. So I'm going to change everything to sine and cosine because that's really about the only thing I can do. Sine x over cosine x minus root 2 sine x equals 0. And then we clear by multiplying everything by cosine x. And we can clear on this one. It's not a complex fraction, but because it is an equation, we are allowed to clear. Okay, so gone. Sine x minus root 2 sine x cosine x. 0 times cosine is staying 0. And you can see now we can factor a GCF. Sine x parentheses, there's a 1 left behind, minus root 2 cosine x equals 0. 0 product property. You have sine of x equals 0 and 1 minus root 2 cosine x equals 0. I am going to take you one more step and let you finish, and then we'll check answers together in class. Sine of x equals 0, that's pretty easy. There's 2 places where that happens. This one you're going to subtract the 1 and then divide the negative root 2. So you get cosine x equals positive 1 over root 2, because when you subtract it's negative, when you divide it's negative, they undo each other. 2 answers, a total of 4 answers. We'll check it together in class. That is it for this lesson.